Hey everybody, it's Miss Suchi. We are going to be talking today in geometry about the area of regular polygons. And remember, a regular polygon is a shape, a polygon, not anything round, but it's got sides. And to be regular, it has to have all sides the same measurement and all angles equal in measurement. So here we go. Investigation area for regular polygons. So here are three examples of regular polygons. These ones are pentagons, hexagons, and 1, 2, 3, 4, 5, 6, 7, 8 octagon here. So if you take a regular polygon, to find the area of it, what you can do is you can chop it up into congruent triangles. And because all the sides are the same length on a regular polygon and all the angles are the same measure, each of these triangles is going to be the same size. So first thing we need to do is recall what is the formula for area of a triangle. So area of a triangle is base times height divided by 2. Now, clearly you can see that nothing is listed as a B for base on here. So what we're representing as the base is actually going to be the side length of the shape itself. So let me highlight that for us. So this side length would be considered the base of the triangle. Now we also need a height, and when we're looking at a height, it has to be perpendicular straight up from the base. So if I look down here in this zoomed in pentagon, we've got the base here, that's considered the side length, and then the height part is actually called the apothem, and that's the distance that is from the center of the polygon perpendicular to the side length. So I'm just going to put a little perpendicular note in there that these two are perpendicular. So that's going to be our height. And then dividing by 2 is just the part of the triangle formula. So once we put all that together, we get one triangle. So depending on the shape size, how many sides it has, we're going to need multiple triangles to find the total area. So up here you can see with this hexagon and with this octagon, we would do base times height, divide by 2, and that's going to get us this one triangle right here. But on this hexagon, I have 1, 2, 3, 4, 4, 5, and 6 triangles all together. So I need that triangle 6 times. So again, what we're going to do is we're going to take the area of one triangle and we're going to multiply by the number of triangles that are in the figure, but that's also the same as the number of sides on the polygon. Okay, so to put it more into polygon terms, instead of base times height, we're going to call the base as our side length, the apothem as our height, and then n is the number of sides or the number of triangles. So if we have the area formula, it's going to be the triangle formula first, base times height divided by 2, and then we're going to multiply that by the number of triangles in the formula, or in the shape, I should say. Now, when we have our side lengths and our number of sides, draw out that pentagon again, S is being repeated on all 5 of those sides. So I would have 5 S's as the perimeter. So there's another way to write this formula, and it's based on the perimeter of the shape. When you put together the side length and the number of sides, that's going to get you the perimeter. So perimeter equals side length times number of sides, which means I can pull those two variables out and replace it with the variable p to get the same formula. So another way to do this would be to take the perimeter of the shape, multiply it by the apothem, and then divide by 2. So both formulas are correct. They both get you to the same result. They tell us how big of an area inside the polygon is. All right, here's some practice. Stop signs in the United States are 750 millimeters across. Okay, 750. Measured from the flat side of the red octagon. Okay, the white, oh, just the red section. Okay, wait, back up. I just need to go to the red portion. Okay, the white board, I think that meant to say border, is 20 millimeters wide. Okay, so that would mean I add 20 millimeters on there and 20 millimeters on there. The perimeter of the entire sign is, okay, I gotta highlight that. Perimeter is 2,616 approximately millimeters. How much sheet metal would be needed to make one sign? I have this broken up down here. Oh, nice. So it breaks it up. Okay, so if I'm looking for, let's see here, what is the side length? Well, I know the perimeter, so I just need to take that perimeter and chop it up into equal parts. So I'm going to take that, what was it, 2,616. 2,616, and I'm going to chop it up into equal parts. How many parts are there? How many sides? 1, 2, 3, 4, 5, 6, 7, 8. Oh, duh, an octagon, a stop sign. Okay, I need my calculator because I can't do that in my head. 2,616 divided by 8. It comes out to 327 millimeters. So I'm going to mark that on the side here, 327 millimeters. Okay, what is the apothem measurement? Well, I know the apothem is from the center. Ugh, that pink doesn't show up very good. It's from the center out to the edge. And so I need to know halfway across the stop sign. So looking all the way across, that was 20, 750, and 20. So I need 20 plus 750 plus 20. What is that? 750 plus 20 plus 20. Okay, I got 790 millimeters all the way across, but apothem is only halfway. So I'm going to take that 790 and chop it in half. 395 millimeters. Okay, so I've got my side length, 327, 395 millimeters for my apothem. Now it says calculate the area of the sign needed in sheet metal. So sheet metal is usually pretty thin, and area would be how much space on that sheet metal that we're looking to punch out that sign from. So we're going to use the area formula, side length times apothem divided by 2 times the number of sides. Now technically, because they gave us the perimeter, we could have just used the perimeter and the apothem measurement. And we could have skipped that first step, which seems smarter to do because that was more work. But I'm just going to plug it in. So side length was 327 times the apothem was 395. Divide by 2 because we're working with triangles. And then multiply by n, which is the number of sides, which remember an octagon has 8 sides. And then if you were going to do this as the perimeter formula, you would take that 2,616 times the apothem divided by 2. Either way, you're going to get the same answer. Okay. Okay. Let me just double check my math here one more time, but I think this is right. Seems like a huge number. 327 times 395 divided by 2 times 8. Yep, that's what I got. All right, this would be millimeters squared because this is an area. All right, so that's how much sheet metal it takes to make a stop sign. All right, more examples. These ones are not as exciting. That stop sign was kind of exciting. Now you can go around and say, I know how much sheet metal it takes to make that stop sign. Because that'll be a very important fact for you. All right, we're going to find the area, or, ooh, these ones are harder. These ones are finding the missing parts. How many of these do we have? Ugh, quite a few. Okay, oops, too far. So here we go. First one says, find capital A. So that's just the area formula flat out. So I'm just going to write that formula. side length times apothem divided by 2 times n. Okay, n would be the number of sides, and that's missing up here. So 1, 2, 3, 4, 5, 6 sides. Okay, total coincidence that the side length and the number of sides happen to be the same thing. That's not always the case. All right, I'm going to plug in my numbers. A is going to be 8. S is going to be 6. Still have the divide by 2 because that's part of the formula. And then n is 6. And then we just plug it all into our calculator. Forgive the noise behind me if you can hear it. My husband and kids are vacuuming and cleaning up. I get to skip out at chores. Haha. All right, so this came out to 144, if I did that right. I feel like I'm using my calculator wrong today. And then I want to put on a label. So area is square units, but they specifically said here that we're working in centimeters. So this would be centimeters squared. All right, this example says find little a, and they give us the big A answer. So we actually have to work backwards, which is not as much fun because it involves a t-chart. So I'm still going to use that same formula, S times A divided by 2 times N. But then I'm going to plug in the 435 in for this capital A this time. You can probably hear my husband in the back. He's probably going to be yelling at my kids. All right, so S is 10. That's going to go in right here for S. Little a is what's missing, so I'm going to leave that in blue so it kind of stands out. And then we've got divide by 2, and then times n. And n is the number of sides again, which happens to be another hexagon, so 6 sides. Okay, now there's multiple ways you can approach this when you're solving with a t-chart. I personally like to just get rid of things one at a time. So I'm going to make this a longer t-chart. Some people might like to condense as much as they can by simplifying and then do the t-chart. I'm not that type of person. I like to do it one thing at a time. So I'm just going to start on the right, and I'm going to get rid of this times 6. Opposite of times 6 is to divide by 6. Okay, 435 divided by 6 comes out to 72.5. Still have the 10, still have the A, still have the divide by 2. Okay, next step, get rid of the divide by 2. That would be times 2. All right, 72.5 times 2 comes out to 145. And we still have the 10, and we still have the A. Just remember, when you do the opposite, those things cancel out. All right, last step, I want to get rid of the 10, but the 10 is being multiplied by the A, so we're going to divide by 10. So A equals 145 divided by 10 is 14.5. So it's up in this problem here. If I go back up, my apothem length right here is 14.5. And I don't think this one had a label. Oh, it did. This says inches squared, so this would be inches. All right. Now we've got 2 more similar problems. So I would like you to try each of these, but if you notice this first problem here doesn't give us the side length, it gives us the perimeter. So the formula you're going to be working with is the one that uses perimeter. So giving you the formula for that one. This one on the right does use the side length and the number of sides in the formula, but it is missing S. Excuse me, so you're going to be doing a t-chart, but we're still going to be working with that original formula. So go ahead and pause and try to figure those out. All right, we're back. Here we go. I'm going to plug in little 8 for little a. The divide by 2 still stays there. P is 30, and that's going to get me my area, so I just need to punch it in. 30 times 8 divided by 2. Area equals 120. This label up here had centimeters. Area is a squared unit, so that is centimeters squared. Okay, next one. We've got capital A given to us. So I'm going to replace that capital A with 237.5. Little s is missing, so I'm going to leave that in blue. Little a is a length of 10. Divide by 2 is part of the formula, and then multiply by the number of sides, which this happens to be a pentagon with 5 sides. And then we're going to do a T-chart. I need to make some more room. Now, if you did your T-chart different than what I'm demonstrating, as long as you're getting the same answer, you're good to go. So opposite of times 5 would be to divide by 5, and then I'm going to cancel that out on both sides, or on that side. And then 237.5 divided by 5. Okay, I get 47.5 left over. Still have the s, still have the 10, still have the divide by 2. Next step would be to multiply by 2. Cancels. 47.5 times 2 is 95. And that's still with an s and a 10. And then I got to get rid of that times 10. The opposite of multiply by 10 would be to divide by 10. 10s cancel. I have s left, which represents side length. 95 divided by 10 comes out to be 9.5. If I go back up and look at the labels here, 9.5 is my side length. 9.5, and this was in millimeters. Fantastic. All right. Oh, yay, last problem. So on this one, they are asking us to find perimeter when we're given the area. So we're going to use the formula that has the perimeter in it. Plug in everything that we know. Capital A is 300. Capital P is what we're missing, so I'm going to leave that as a P. Little a is 6, and divide by 2 is part of the formula. And again, because we're missing something within the equation, we need to do a T-chart. So go ahead and try to solve for the perimeter. Okay, here's the correct steps. Again, you might find a different path. Oh, that's not correct. On how to solve this. And as long as you're getting the same end result, that is fine. So opposite of divide by 2 is times 2. We'd have 600 equals P times 6. And then opposite of times 6 would be to divide by 6. So our perimeter would equal 100. Now we could go even a step further based on this picture. Oh, sorry, this would be 100 inches. We could go a step further and figure out each side length because we have the number of sides here. So since this is a pentagon, the number of sides is 5. I could take that 100 and chop it into 5 equal parts and know that each side is a length of 20 inches. And that would make that perimeter of 100. All right, there's our summary. So that tells us that our work today is done. Thanks, everybody.